This month, I shake it all about and make a pinching motion. A common issue I've come across over the course of my lacrosse career is the head coming loose during a game. I haven't been so unlucky where it's completely flown off, but I've seen it happen to other people. One of the main reasons for that is we're not using the full holding power of the screw. So when it's placed into the shaft, it's only holding on two of the threads, which is not the best use of its clamping force. We need something that will engage all the threads, increasing the clamp of the screw and also adding more friction to resist backing out. As with most projects, we start with some measurements. We'll go 18 for that distance, about 23 for this one. We're leaving a little bit of air gap so that our piece can slide in and out relatively easily. This will be 11.4, and then we'll do the skinny bit, which I think we're going to go with 5.4. And the last measurement is from the top of the shaft to roughly the middle of the hole. And so for that one, it looks like we're going to go with about 15 millimeters. Now we can move into Fusion and start building our file. Starting off in our first sketch where we are going to rough out the basic shape, we took every measurement we made and halved it to create some guides to place our lines. Starting with 5.7, which is half of 11.4, 11.5, which is half of 23, and so on until we've represented all the measurements that we took. Once all our guides were in there, we drew this shape here as kind of like a squiggly line, and that's our base from which we mirror on this axis here and this axis here so that we can create our fully closed shape, which will eventually become our extrusion profile. Now, there are multiple ways that you could do this. You could also have done it with two rectangles and then trimmed all the bits that cross over out. There's 1,000 ways to do anything in CAD, and it's all up to personal preference, essentially. Now, next step is to extrude our profile. We chose to go with 30 millimeters distance, which is double what we measured from the top of the shaft to the center hole. Next step is to smooth off some of the hard corners, make it match the shape a little bit more, and just generally get rid of any hard edges that might catch when we try and install it in the shaft. The next step is to create a sketch to build our screw hole. So we will place it on this plane here, and then if we open it up, you can see we've built some reference geometry. So we have our 15 millimeter measurement from the top. We've also aligned it with the midpoint of this plane so that we can get our circle right smack dab in the middle. And we made it 3.25 millimeters, which we measured as the minor diameter of the screw. So if you look at the screw from the side, you can see there's kind of like peaks and troughs. So we measure trough to trough, or the root of the screw thread, and that was 3.25 millimeters. Sizing to the minor diameter of the screw thread enables the thread itself to bite into the material that we're going to print this out of, so then we get better hold with our finished product. With the hole cut, all that's left to do is slice it up and get it on the printer. Assembly is pretty simple. We take the piece that we've printed, make sure the holes are facing the same way as the holes in the shaft, slide it in top, place the head on top, tip it over, give it a bit of a shake so that everything slides into place and the holes are aligned, and then pop the screw in and tighten her down. The biggest thing I noticed putting it back together is you don't feel like you're going to strip the shaft out. You can tighten it down really snug, more snug than you could before, without it feeling like it's gonna just strip out on you, and then you're gonna have to put an even bigger screw in later. With it all snug down, it's really, really tight, and there's no chance of this head flying off anytime soon.